All right, and our tour of boredom continues. We're going to keep cleaning up this big old data set we obtained from the census in episode 15. So if you haven't seen that video, it would be wise of you to go ahead and do so. If you recall, we took those column names and applied them to the columns, and now we still have a giant unintelligible data set, but we're one step closer to making it something we can understand. So let's see what we need to do next. So we should probably start our cleanup with some goals in mind, and we didn't do that, but let's just go ahead and make one up now. Let's say that we're interested in looking specifically just at the estimates from this set of data. And if we look closely, we can see we have much more than that. For each thing that the census measures here, we have an estimate, we have a margin of error, we have a percentage of the people in that county or in the structures in that county that fall into that category, and we have a percentage margin of error. So that's a lot of information, and we're going to say it's more than we need. We're going to say we only want to look at the estimates of these cases, not on a percentage basis. So how are we going to go about doing that? We're going to subset this big old data frame to just those columns that have the name estimate to begin with, because that's a common property of all those columns. So how do we go about doing that? And what we can do is use the grep function. And if we look at what grep does, works with regular expressions, we'll see that what it does, it's going to launch my HTTP thing, is it's going to get a pattern and match it out of a set here. So I'm going to grep estimate colon, we'll try that, from the call names here. Let's see what we get. And we'll run this line. Look, those are the columns that have estimate as their start. So what we're going to do is we're going to make another data frame, and that data frame will have only the columns from our ACS data frame that have estimate at the start of their name, or rather estimate semicolon. And what we need to do to make that subset, we're going to CNC the data frame or give it a name. We'll just call it estimates. And we will assign it ACS data. And we'll say all the rows, so space, comma, all of the columns. Let's start with estimate. We'll have to use that grep command to get that list of columns again. You'll see I made an initial mistake here. I had estimates as the phrase I was searching for with grep. That's not what I wanted. I just want plain old estimate. So if I run that, and then we look at the first row, you'll see we have a bunch of rows still, but fewer of them, and they all begin with estimate, and they all have numbers. So if we take a look here, we can start already to have a more intelligible set of information to look at. And we'll say, okay, look at this. How many times in the first county in the list we had a structure built between 70 and 79? That's 3,205 in whatever county that is. But we'll note that that first row here of our data doesn't have the county name in it because we failed to get the county to come over, because the county column doesn't start with estimate. So data cleanup is a two-edged sword. If you cut things out, you may cut out stuff you need. You have to be very circumspect and careful. And so we're going to go ahead and need to grab that column and throw it back on our estimates data frame. Let's go ahead and find out which column we need. And I'm just going to go ahead to do that and review the column names of our initial ACS data frame. And it's going to be a huge old list. Remember, we had 500 of these things. But once I finish letting the console print them all out, which admittedly this is a little bit of a backwards way to do it, what I can do is try to scroll to the top, not get there, and pretend I can get there maybe, or just imagine I can get there and see if we can remember what they are. Since I can't, and pretending and imagining doesn't help us a lot, I'm going to cheat. We'll jump back into LibreOffice, our spreadsheet, and look at that metadata.csv. We'll see that geodisplay label or geography is the thing that we need, or rather we'll know that from working with the census before. And we can actually just rip that column straight off the big data frame and put it on the smaller data frame only because they have the same number of rows, so they're going to match up, and we can see that. If we recall, we can use our dim command rather. So we'll look at the dimensions of ACS data, and we'll see there's 3,000 some rows, but 567 columns. In a similar way, we can look at the dimensions of estimates. if we spell it correctly. And see, we have the same number of rows. So let's go ahead and grab that first column, which would be ACS data, geography. And we're going to go ahead and assign that to estimates, geography. Or let's just call it county. Just like that. And so now when we re-examine that first row of estimates, we'll get a whole bunch of that same output. But look, we were looking at Autauga County, Alabama. And forgive me, folks in Alabama, if that's not how you say it, but that's my best approximation. So we've done a lot of cleanup here, and we now have a new data frame that simply gives us counties with estimates of various variables from the census, from that American Community Survey for the period of time between 2007 and 2011. But let's take it one step further. Let's say we just want to look at one particular piece of data. And the piece of data we're looking for is going to be how many people in each county live in a boat, van, or RV, which it turns out is something the census measures. Here's how we'd go about doing it. And in a similar way to before, we're just going to subset with that grep command. We're going to just grab boat because none of the other columns have it. And when we run this command, estimates just those columns which have boat in the name. It's only going to be one column, so it spits it out like a vector. Let's go ahead and assign that then to a vector called, oh shucks, let's just say BV for boats, vans, and RVs. And let's make a data frame of just those county names from before. So the geography, BVR gets data.frame of that vector there, which is the column with just the county names, and BVR. And now let's look at data BVR. Check it out. Here we have, once again, a relatively large list, but we've taken that big old data frame and got just a particular piece of data that we wanted out of it. And that particular piece of data, once again, is the number of housing units that are boats, RVs, or vans, which is a crazy way to live. But you can see that it takes time, it takes diligence, it takes close attention, it takes a lot of effort to get your data into the shape you want it to be. We wound up with a data frame that just has county names and one count in it, but we started with a bunch of unlabeled columns that had all sorts of information in them, and that's a quick lesson in munging your data. So again, my name's Ed. I work for My Bringback, and I attempt to teach you how to do some data analysis in R. So I appreciate your patience through these last two videos. Just wanted to make sure that I wasn't just giving you quick, slick, easy, shiny things and showing you that a lot of this takes diligence and hard work. So stick with me, keep applying that diligence and hard work, and we'll get you there, man. Subscribe on YouTube, follow the channels, and we'll make good things happen.